This is Unit 13, Lesson 2. We are simplifying rational expressions, and your objective is right here. Now, we need to know what this means. A rational expression is simplified if its numerator and denominator have no factors in common other than 1 and -1. Okay, so a rational expression is something that can be written like a fraction. Okay, and again, simplified if its numerator and denominator have no factors in common other than 1 and -1. Okay, now factors. Okay, for example, here's what I mean. We're talking 2 times 3 over 2 times 4, for example. Okay, so let's say this would be like 6/8. 6/8 is 2 times 3 over 2 times 4. They have a common factor. We can divide both of those by 2 and get 3/4. Okay? Whereas if we do something like this, 2 plus 3 over 2 plus 4, okay, that's the same as 5/6. That cannot be simplified. Okay? So these are called terms because they are added. Whereas these over here are factors because they are multiplied. Okay? So these right here, factors, can be simplified. We could cross these out and make it 3/4 because we could divide by 2. Whereas these are terms because they're added together. We cannot simplify them when they look like this. Even though we got 2's here, it looks like we should be able to simplify this. Okay, this shows that, again, this is 5/6. We cannot simplify that even if they have terms in common. They have to have factors that are multiplied together in common, except for 1 and -1. So let's go ahead and work on simplifying some rational expressions. Okay, first one, 28 over 35. Okay, so we need to think of what's a common factor of 28 and 35. Well, I know that one way I could write 28 is 7 times 4, and I could write 35 as 7 times 5. So they each have a common factor, something that multiplies together to get 28 and multiplies together to get 35. So we can simplify these and get 4/5. Again, the reason we can do that is because these are factors because they're being multiplied. Okay? On this one here, if we look, we got x squared on top and x squared on bottom. However, this is a term because it's being added here. Okay? So this expression is factored up top, but this one's not completely factored. We could rewrite this as x times x squared plus 6 on top over, and x squared is x times x. Okay? Now, do I have any common factors? Well, my factors on top are x and x squared plus 6 because that's what I'm multiplying together. And here I got x times x. So I've got a common factor right here of x because I'm multiplying by those. So my simplified expression is x squared plus 6 over x. And I can't simplify these because this is a term, okay, not a factor. And I can't factor this out anymore. Okay, there's no way I can factor x squared plus 6. So I'm done. That is simplified. Okay, now this one. Again, we're factored here. Well, let's think about our terms. I've got 2 times x on the top, so one term is 2, and one term is x. Then on the bottom, I'm taking 2 times x plus 5. So again, 2 is a factor, and x plus 5 is a factor. So I can go ahead and simplify the 2's because they're being multiplied by something. So then I get x over x plus 5. Again, can't simplify these because this is not a factor. This is a term. It's being added to something else. So I'm done. Okay? Now the one down here. Okay? On top, I don't have any factors. My only factor is 5x plus 3 because these are terms. I'm adding them together. So this is a whole big factor on top, and this on bottom is a whole big factor. Well, neither one of the factors are exactly the same, so I cannot simplify it. So my answer is 5x plus 3 over x plus 3. That is simplified already because, again, there's no separate factors up here. This whole thing is a factor on top because they're being added together, and this whole thing is the factor on the bottom. Okay, so no simplifying can be done there. Alright, now let's go ahead and do some more examples with these. Okay, on this example here, we want to simplify this rational expression. Okay, so the very first thing we do is factor the numerator and the denominator if it is possible. Okay, and then we're going to simplify. So the very first thing I do is factor the numerator if I can. Well, I know that 2x squared minus 6x, those have a greatest common factor of 2x. So I'm going to pull that out and say it's 2x times, and 2x times x would give me 2x squared, minus 2x times 3 would give me 6x. So my two factors are 2x and x minus 3. Well, I could break 6x squared apart as well. Okay, I could say that that's the same as 2 times 3 times x times x. Okay, so now let's think about what factors I have here. On top, I've got 2 as factors, so I can cross those out. I've also got x as factors, an x and an x. Okay? Well, now this is a factor that's left over. I have an x minus 3 as a factor on top, but no x minus 3 on bottom. Okay? So now I'm done simplifying. I've got x minus 3 over 3x. Okay? Again, we have no factors in common because this whole thing is a factor since it's separated by a minus sign. And then we have two factors here, 3 and x, but we don't have a 3 on, just a 3 on top or just an x on top. So we are done. Okay, that is it. That's all the simplifying that we can do on that one. Okay, and let's move on to the next example. Okay, here we go with the next example. Again, the first step is to factor the top and factor the bottom, and then simplify the common factors that we can. Well, the top, we got 4 minus x squared. That's one of those special product patterns that we had. Okay, that's the a squared minus b squared, the difference of squares pattern. Okay, well that factors out into a minus b times a plus b. Alright, so we're going to take the top and make it 2 minus x times 2 plus x. Is how that one will happen. Okay. Then on bottom we have to factor x squared minus x minus 2. Well, if I do on the denominator, okay, if I take a times c, that's negative 2. Now with the factors of negative 2, that add up to negative 1. So that would be negative 2 times positive 1. Okay. So again, we use the box method. Okay, we can do x squared minus 2x plus 1x minus 2 to factor this out. Again, all we're doing right now is factoring the bottom. The bottom, sorry about that. Well, if I go to the left here, the greatest common factor of x squared and negative 2x is 1x. Greatest common factor of 1x and negative 2 is 1. And if I go up here, the greatest common factor of x squared and 1x is x. And the greatest common factor of negative 2x and negative 2 is negative 2. So I've got x plus 1 times x minus 2. Okay? Well, so if I'm looking at factors I can cross out, I got 2 minus x on top, and I don't have one of those on the bottom. I got 2 plus x on top, but I don't have one of those on the bottom. So it looks like I should be done. However, there's something here that we can recognize called opposite factors. Okay? I mean, if I take a little closer look at the ones that look similar, I might be able to change one of them so that will match up with another one. For example, this is a positive 2 up here and a negative 2 down here. And this is a negative x and this is a positive x. So these are completely opposite factors. Okay, again, completely opposite factors. We got a positive 2, negative 2, a negative x, and a positive x. So what I can do is I can take out a negative 1 out of this top one. Okay, so I can make the top one negative 1 times, well, negative 1 times negative 2 will give me positive 2, and negative 1 times positive x will give me negative x. Okay, so I changed this one. The reason why I did that is now look at this. I've got a negative 2 here, and a negative 2 here, and a positive x here, and a positive x here. So these are the same factor, just written differently now. Okay? So I'm going to leave the other one the same, and leave the bottom one the same. Okay? Because now I have some opposite factors. I've got opposite factors, or I got the same factors, sorry, right here. That can cancel. Because negative 2 plus x is the same as x minus 2, or x plus negative 2. So now these cancel. So now on top I've got negative 1 times 2 plus x all over x plus 1. Okay? And another way to write that is if we've got negative 1 out in front, really we can just throw that as a negative sign out in front of the whole thing. So it's negative 2 plus x over x plus 1. Okay? So that is how we can simplify that one when we get opposite factors. Now that's a tricky thing, but again, what we're looking for here is when we see things that look very close to being the same, is if they're completely opposite of each other, like negative x and positive 2 and negative 2, they're completely opposite. Okay, both parts are opposite, so we can pull out a negative 1 to make them the same thing. Okay, if I would have tried that here, if I would have pulled out negative 1, then I would have gotten negative 2 and negative x, which would not be complete opposites, because the negative 2 would have been opposites, but then we would have had negative, or they wouldn't have been the same, sorry, the negative 2's would have been the same, and then the x would have been a negative x, so would not have worked out to go with this one. Alright, we got one more example. This example says, what values of x is the expression undefined? Okay, undefined, remember, when is something undefined? When is a fraction undefined? And it's when the denominator equals 0. Okay? Because we cannot divide by 0. So we cannot have 0 on the bottom. So I want to know what values of x will give me 0 on the bottom. Okay, so basically I have to figure out how can I make this bottom equal 0. So I'm going to set each factor of this equal to 0. Because let's say that this one was 0. 0 times this would be 0. Okay, and if this factor equals 0, then 0 times this would equal 0. Alright, so all I'm going to do is take x plus 2 and set it equal to 0, and x minus 2 and set it equal to 0. I'm going to set each of the factors on the bottom equal to 0. Okay, so if there's one factor on the bottom, you set that one factor equal to 0. If there's two factors, you set them both equal to 0. If there's three, you set all three equal to 0. Okay, but any of these factors will make the expression undefined. So we're going to get x equals negative 2 and x equals positive 2. Okay, so x equals negative 2 and positive 2. Those values will make the expression undefined. So if I put negative 2 in, negative 2 plus 2 is 0, which will make this whole thing 0 out. And if I put 2 in, 2 minus 2 is 0, will make that whole thing 0 out. Okay, that's your lesson on simplifying radical expressions. It gets pretty tricky, but I think you guys can handle it. So happy homeworking.